Hey, welcome back. I hope you're enjoying working with statistics here, and we're going to go on with working with continuous data. And in this presentation, it's mainly looking at grouping of data so that people can see more clearly what all the numbers mean. People generally are frightened of numbers, so we're going to group the data, and there's going to be a little bit of discrete data in this presentation as well. So look around the screen. We can see what we're trying to do. We've done a bit of this with discrete data. Tally columns and so on. So look at the representation for continuous data, 40 but less than 50, so it could go up to 49.999999. As soon as it hits 50, it's in the next group and that sort of thing. So continuous data, remember, is continuous. Every possible value between integral values could be included. Things like heights and weights. If you're accurate enough in measuring them, you're going to get lots of decimal places. And of course, the old histogram here. Please note that when it's continuous data, they butt up against each other, all the columns. Technically, if it's discrete data, there should always be a gap between the columns, indicating that. So, you know, if you have 40 up to 50, and then this would be 51, etc. Okay, so really, I suppose here, we might make this, just try and erase this there now, that's better. We might go 41 to 50, 51 to 60. Because there's nothing between those whole number values, 50 and 51, we should keep those columns separate, indicating that this is the difference between discrete and continuous. You can't have a continuum. There's nothing between integer values, that sort of thing. Okay, so remember, keep the columns separate in discrete data, keep the columns butted up against each other for continuous data. Okay, so do you remember the way in which to tally data? You scan the data once, and each entry you put into a particular group with a tally mark, and the fifth tally mark makes a bundle of 5, making it easier rather than in this one here, count 10 strokes. You've got 2 5s, and you can easily see you've got 10. A little bit of revision there. Are you ready to go? Let's rock and roll here. Let's have a look and see some of the things that we want to look at. So here we are. Continuous data is numerical data which has values within a continuous range. Any value is possible between integral values, we're saying here. It's continuous, no breaks. Okay, histograms. What's a histogram? You've seen that before, and we just had it back on the first screen there. Things like weights. You can possibly get weights in between any value, not just 60 kilograms, 70 kilograms, but 69.9, or if you're accurate enough, 69.999, etc. So this is a vertical column graph used to represent continuous group data. No gaps. Okay, there's a big difference between discrete data column graphs, we call them, don't we, and histogram columns. Okay, we always use the same bar widths, okay, because this is a proper mathematical scale. We don't just use different widths for the same interval, okay, so we put equal intervals and have a proper mathematical scale here. Okay. And the height here, let's look at this. The height must reflect the frequency. So this is the number of times we got scores in that group, how many scores are in that group. And this could be changed to, we saw this before, relative frequency. Relative frequency is the fraction of scores in that group. And that leads on to us being able to calculate a percentage, and that leads on to what's the probability of getting a score in that group. We're going to be doing a bit of that later on. So you could put frequency, or you could put the frequency as a fraction out of the total, and thereby start to work towards percentages and probability. That's why statistics and probability are very closely connected. We'll be looking at that a bit later on. It's exciting stuff. Okay, come down and see what we can do. Here's an example. Okay, we've got a lot of data points here. The time in minutes for shoppers to exit a shopping centre. How long were they in there, in other words? People don't like numbers. Gets confusing. So let's organise the data into a frequency table. And look at this representation here. You might not have seen this before. 0 minutes, didn't stay at all, didn't even go in there, up to 10 minutes, but less than 10. So if they were in there for 9.6 minutes, then they're in this group. As soon as they hit 10, 10 up to less than 20. Okay, so what do? How do we create this and organise this data? You read the first one and put a light line through it, 17. You go and find its group, so it's there, and you put a dash in there. Then you go to 12, that's in here as well. Put another one, hang on, we'll just get rid of that. Put another one, and so on. A light line through it so you can still read it. You scan the data once, scan data once. Okay, and record it. Don't go through and look for all in a particular group. It take too long. Then after you've got your bundles, your tally, you look at them and there's 3. Look at this, it's a bundle of 5. Look at this, it's bundle of 10. 2 bundles of 5 is a bundle of 10. Here there are 7. Okay, so you make your frequency. Now you're ready to draw your histogram. So they've already told you the sort of group intervals. Often, and we'll come to this later on, you have to work out what your group intervals are going to be yourself. And we usually aim for between 5 to 10 groups. Okay, or around that. We'll come to a little rule they sometimes use for this. So this is quite nice. We've got 7 groups here. 3, 4, 5, 6, 7 groups. So that looks quite nicely spread out. And you draw a column up. So you have a scale along here, 0 to 10, etc. 10, 20, using the same number of squares for the same width. And then you draw a column up to represent how many in that group. So there'll be 5 in the 10 to 20 group, this one here. Do you get it? Fairly straightforward, same as a column graph with discrete data. But this time, the columns are all butted up against each other, and we call it a histogram. Okay, maybe you saw this in junior maths. Let's go and have a look. Come and have a look down here now, and do a couple. Okay, I think we've got 3 or 4 problems here. So there's lots of numbers. People don't like numbers. Let's make it easy for them to understand. So I want you to pause the presentation, have a go at question 1, then you can forward it and look at the answers down below. And backwards and forwards you can toggle between the questions and the answers. There's question 1 and 2. Pause it, have a go. I'll take you down here now. There's only 3 questions in this batch. Here's the 3rd question. Okay, and let's look at the answers now. They are nicely laid out. These screen clippings are from Hayes and Harris publications or maths applications. Okay, how'd you go? Get a few right? Go back and check if you're not sure. All right, let's go down now and have a look at the next thing we want to do. And this is measures of centres of distributions. Oh, what does that mean? Well, I'll tell you what it means. People see all this data and say, but what's the average house price? What's about the middle of the range? You know, all these questions. They don't want to look at pictures even. They don't want numbers. They want to say, well, if I'm going to buy a property in this area, how much should I be aiming for? What's the middle of the range or something like that? What's the average? And so we get 2 basic measures of the centre usually. The mean, which a lot of people like. You add them all up and average them out, adding all the scores and divide by the total number of scores. The mean is denoted by what's called X bar. We say X bar is a symbol for the mean. A lot of people like this. We'll have a look at whether it's always the best one to use. The median is the actual middle score. It doesn't add on the ones above it or below it. It just bonks for the middle and says that's the middle when you put all the scores in order. Okay, now let's have a look up here along this whole row of diagrams. And I think I'm raising the problem with you, aren't I? What if the distribution is like this? What would you choose, the mean or median? It's bimodal, isn't it, basically? Got 2 separate peaks. Ooh, adding them all up and dividing by how many there were, getting the mean, would that be the best? Or with a median? Interesting problem. This is almost symmetrical. And the mode would do here. Okay, the mode wouldn't do here. You notice I've dropped the mode out because usually there can be more than one modal value, so we don't often use that as the centre. We could use it here because it's roughly in the centre. I think we could use the mean or median there. What about this one? It's got this tail on it here. Do you remember what sort of skewness that is? There's some symmetry. I think you'd say this is skewed high or positively further to the right, because that's where the lump is that destroys the symmetry that we've got elsewhere, slightly skewed positively. So if we're adding up the values and dividing how many there are, these few are going to have a fairly big effect because they're a lot bigger than the others. So maybe we wouldn't choose the mean there. So can you see our problem? There isn't a symmetry in lots of distributions, and the mean might give us a false impression. Let's come down and have a look at an example I've got for you here. This is a Huddy example. So we've got here some scores. I think there are 11 scores here. So we'll put n equals 11 in this sample. Okay. So you're trying to say to people, on the average, what's the score that people get? Or the number of times they play this game in a week. Let's say it's a computer game. And everyone says, oh, the kids are playing too much on that computer there or on their phone. This game is absorbing their whole life. And you say, well, no, hang on. On the average, let's work out the average. X bar, the mean. On the average, add up the 11 people you know, your mates and so on. Divide by 11. On the average, people play 23.6 times a week. And you might say, gee, that sounds high. I only play 16 times a week. I'll quote the median. Let's work out the median. Now, the median is not the 11th score here. We've got 11 scores. It's actually the middle score, which is these 17s, 4, 5. So that's the 5th score, 6th score, 7th score. So this 17 is right in the middle. It's the middle of the 11 scores. He made a mistake there. Middle of the 11 scores. It's actually the 6th one. And I'll show you how to do that in a minute. So there's the median. And you might like to quote that. Because really, these two dudes who are spending, or you are playing the game that many times a week, are not on the average the same, are they? But when you add up their 56 and 58, even though there are only two of them, it makes the whole lot look bigger. So, get my example? You might like to quote to your parents, oh, on the average, me and my mates only play the game 17 times a week or something like that, rather than quote this. Can you see the idea that the mean can be distorted or can be affected by a few low or high scores? Okay, so we need to avoid using it where that's going to give a false impression. So this scenario here, or come back up the top here. Hang on, see if I can get this little creature up here. See here? That might have been what would happen there. Those few high ones might have elevated the average quite a bit. So, getting the idea. Okay, so be careful with the mean. It is what we call a non-resistant measure of the centre. It doesn't resist the effect of a couple of high ones. The median is more resistant to that pull, up or down, due to the effect of a couple of high or low scores, or a few high or low scores, which are out of the usual range of the scores, or spread of the scores. Okay, we might discuss that with your teacher and the rest of the class. Let's go down and play with that a little bit here. Here we are. Here's how you work out the median. You know how to get the mean. X bar. X bar is the sum of all scores divided by the number, n, the number of scores. Okay, been using that for a while probably. When you have n scores though, the median is the middle one. And we do add 1 to the total number of scores divided by 2. So in that example above, I had 11 scores. 11 plus 1 is 12 divided by 2. The sixth score was right in the middle. It had 500, then it was the sixth score, and then it had 5 above it. So it's dead set in the middle. So for odd number of scores, the actual middle is one of the actual scores. But when you have an even number of scores, when you add 1, that's 13, 12 plus 1, 13 divided by 2, it's a 6.5 score. So it's in between the 6th and the 7th. So below the 6 will be 5 scores, then there'll be the 6th score, then the 7th score, and above the 7th score there'll be 5 scores. So somewhere in there is the middle. So you actually have to find the average of the 6th and 7th score. So add them up and divide by 2, halfway between the two. You may have seen this before. Okay, are you ready to have a go? Come down now and let's have a look. Here's your first little problem. It's a Huddy problem here. So I've given you a table of values. Read it carefully. These are thousands of dollars that these company directors get. Okay, 100,000 to 150,000. There's 5 people get that. 150,000 to 200,000. 11 people get that. 200,000 to 250,000. 7 people. Nobody gets in that range. Then 300 to 350,000. Oh, these are big numbers now. Okay, there's a few people getting those. So those 5 up there are actually not quite outliers, but they're certainly not representative of the other 23. 23 people in this group and 5 up here. If you want to say, company directors get this amount and give people some idea of the middle, would you use the mean? Would you use the average? If you did, do you think these up here would have a disproportionate effect? Would they pull the average up because there's a few very high ones? Or would you choose the median? The median, what is this? There's 28 scores here. 28 scores. Let's work out where the median is. 28 plus 1 divided by 2. 29 on 2 is the 14.5th score. So somewhere between the 14th and the 15th, the average of those two. So where's the 14th? Well, there's 5 scores there. The next 11, right up to the 16th, are in this group. So you probably say, well, the best you could say is probably up the top end of the 150 to 200 group. There's a huge range here. But most of them are clustered down here, aren't they? 23 of them are here and a couple up here. So maybe you should not use the mean, which will give an emphasis to these 5 by adding on their high scores. You might actually just quote the median and say, well, usually we expect you to get this amount of money. The median score is a better indication of where the group of company directors are lying. Get the idea? Okay, let's come down, let's do some more. Okay. Now with this work, because we're often using lots of big numbers or lots of numbers, then we use graphics calculator. So I'm going to go through the Casio, and you go to stat mode, and you can clear list 1 and list 2, or you can just overwrite the data. Okay, and then we will enter data in list 1. Okay, and if you enter data in list 1, you then hit, you want to do a calculation. Well, you can hit, we did this before, you can hit F1 there and come up with graph mode, or we might want to do a calculation, so you would hit F2 to do a calculation. You also have to set it up though, so when you've entered the data and you do that calculation, you have to hit set, okay? And if you hit set, you have to set up, and just go back up here, you have to set up which list you want the calculator to refer to. So list 1 with a frequency of 1, and set that up, and just get rid of that. and set that up there. We'll come down a little bit because that's disturbing the bottom there. Okay, and then you can hit 1 there. Once you've set up the calculator to show it's going to work with list 1 data with a frequency of 1, hit 1 there and you get this screen here. There's your X bar. Okay, whatever data. I think they've put in numbers 1 to 9 there. No, they've got some other data set, doesn't matter. Now, if you scroll down that window, scroll down with the arrow key there on the button, okay, and come down, you'll get down to the 5-number summary, just down below there, and there's the median. 5-number summaries we use in sketching box plots. We'll be doing that a bit later on. So you can find the mean and the median there from the calculator. Okay, so just watch that. We've done a little bit with that before, so you might go back and have a look at the earlier presentations. So if you're doing this work, it's very convenient to use a calculator. So here's some data. And this time you'll put 1 set in list 1. There's not group data here. Okay, and the other set in list 2. So when you set the calculator up, put which group you're working with so you don't confuse it. And then check which team had the higher mean score. You could also check their median, couldn't you? Okay, so we're going to use a calculator. Just notice what Hayes and Harris are saying here. The real world uses computer packages, particularly spreadsheeting with Excel. So you might check with your teacher, how do you set up a spreadsheet? Because you can print out data and it's much quicker than a calculator. A calculator is like a mini computer. That's not the real thing. Okay, so what I want you to do is to enter this data into your calculator because you're going to use technology or a computer package. And what we want to do is to work out the mean and median for these. And maybe you might want to comment on the difference between the mean and median, or have a class discussion on that. Okay, so pause the presentation. Here's 4 questions. I'm going to show you the answers in a minute now. Okay, come down and let's look at the answers here. Those 4 questions. Okay, have a look, see what you think. Comment on the differences between the mean and median, and perhaps why those differences have occurred. All right, let's go on and have a look at grouping some data now, as we mentioned before. And I'm going to go back to grouping discrete data. So quite often you will have a discrete set of data here, number of matches in a matchbox, and how many matchboxes had that many in them. Okay, so you've done your tally stuff and all that, and now what we want to do is find the mean number of matches per box and the median number. Now, we mentioned this before, when you group data, sometimes you lose information. We haven't lost it here because there's no actually grouping in here. We've got 2 of the actual number of matches in a box there. Okay, so let's have a look. What do? With a Casio, you go to Stat, you put list 1 as the number of matches, that's the data points, and list 2 is the frequency. So let's just make sure here that we're going to get that right. We've got to go to Set. So here we've got the data list 1 and the frequency list 2, and we're going to go to Calc. If you hit Calc, which is F2, you'll get the Set window. And if you go to the Set window here, you can say 1 variable list 1, 1 variable frequency list 2. In the last set of data, we had the frequency of each value occurring once, so we had frequency 1 there. Okay, and it enables you to say how many times each score has occurred. We've seen this in earlier presentations. So then if you exit that screen, and I talk about up here, you can read those as well, and if you exit that screen and hit 1 there, like we did before, there it is, there's X bar, and you can scroll down and get the median as well. So just remember here, with group data, a list will be list 1, the scores, and list 2, don't forget to go to Set, list 2 set up as a frequency. So it tells the calculator that these scores are not just occurring once each, they are occurring multiple times, and that list 1 matches, or list 2 matches with list 1. All right, are you ready? Okay, let's have a look. Here's some problems. 5, 6 and 7, I'll scroll down to get 7 in a minute. Number of screws in a packet, and it's supposed to contain 60. How correct are they? So they measure each the number in each packet and how many times each one occurs. On the average is the mean of all those packets 60, like it's supposed to be. Quality control again. Statistics is very important in quality control. And what about the median number? Okay, comment on these results. Which of the two measures more reliable? Okay, what do you think? All right, so try 5 and 6, and I'll pause the presentation and then I'll show you the answers in a minute. We'll go down to 7. So there's the third one there. So again, have a look, think about what the numbers are saying about the data and how the data looks. All right, pause it, have a go. Here come the answers. Okay, there are some answers for you. All right, I hope you're going all right. Check with your teacher, check with your mates and see what's happening there. All right, let's group some interval data. This is continuous data now. So what we're going to do, when you've grouped it into class intervals, it's not possible to find the measure of the centre directly, is it? You've lost the original data. So you've lost information, remember, when you're grouping. Lost info, because you put it into groups. So what we're going to use is an estimate of the original data, which is the midpoint. So you find the average of the two ends. So in a group like this, 40 but less than 50, you have 40 plus 50 divided by 2, the middle point is 45. So you're going to say, basically, that all the scores in that group, because you've lost the actual scores, are all going to be considered scores of 45. Midpoint of a discrete data set 10 to 19 is 14.5. So don't have to be whole numbers now. It's the mean of the two ends. And the idea, you've lost the information, come up here, and so you're going to assume that all data points within that group were midpoints. Just remember a revision here. The modal class is the class with the highest number occurring in it, the mode. All right, come down now. Are you ready to have a go? Let's look at an example here from Hayes and Harris. Here's a histogram, and we're going to ask you to read off. Here's another way of representing it, going up in 5s. So this group is 240, but less than 245. Here it is down here. Okay, so we're going to go from a histogram back to a frequency table. Recognising that we don't know what the scores were, they've been grouped, so we're going to work out the middle point, because we want to do some means and medians. What are we going to put into the calculator if you've lost the data? So you're going to use the midpoint as an estimate of all of those scores. So there's 6 in this group. So what's the midpoint of the group? Add up the two endpoints, divide by 2. We're going to say those 6 scores were all going to be estimated as 252.5. You're actually saying, on the average, those 6 had an average of 252.5. So find the modal class, find the mean. So let's go and do it on the calculator, in the median. Okay. And we can do the modal, can't we? We can do the modal, here it is here. There were 7 hits of distance between 260 and 265, which is more than any class. So the modal class is that class there with the most in it. Okay, let's go down and do the rest of it on the calculator. We'll do the Casio. You can read about the others. We're into the midpoints. Here's the difference. Put the midpoints into list 1, and then, so go to calc, which is F2. After you put the midpoints into list 1 and the frequency list 2, then go to set. So you make sure you've set the calculator up and it knows X list is list 1 and frequency is list 2. And as we did before, if you hit then 1 there, then here we go. we get a mean, and if we scroll down, you'll get the median, and you can just read those off. Okay, they've got a question here. The median is given here as one of the midpoints. There it is there. Why would that be the case? Okay, think about that for discussion. Okay, why is it the case? Well, because the median is one of the scores, isn't it? Okay, the median is a middle score. So it's going to be a midpoint because we've lost the actual original scores. The mean could be anything because you add up all the scores and divide by how many there are. And all the scores are deemed to be the midpoints of the groups because we've lost it. We've lost the original scores. But the middle score, when they put in order, will be one of the midpoints. Okay, because we're assuming the scores within a group are all midpoint values. There is another way of interpolation there that you can estimate it, but that's beyond this particular course. Okay, are you ready? There's an example. Have a look at this now. A few little problems here. 8, 9 and 10, all basically calculator work here. Okay, just remember, we've lost the information. We're going to assume that the scores within any group, these two, all occurred in the midpoint of the group. So add up the two endpoints, divide by 2, and enter that as your score for that particular lot within that group. Okay, pause it, have a go. Go down to 11 now. Okay, now I want to show you the answers in a minute. So pause it, have a work, do a bit of work on those, and then we'll come down here, and there are our final answers. So we're stepping up quite a bit now. We're coming up from the junior maths. This was still basically junior maths here now, and we want to develop that into something a little bit more statistically important in our everyday lives and in analysing data that people present, or lots of numbers that people present. All right, look, I hope you've enjoyed this presentation. There's more to come, and it does get exciting. It's a very relevant, this area of mathematics is very relevant to our everyday lives, to be good consumers. Okay, so from me now, it's cheers for now. Catch you in the next presentation.